Hello, everyone, and thank you for attending today's webinar, Efficient Path and Slice Management with Automation, sponsored by Juniper Networks. Before we begin, I want to cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit them to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask you for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Readings Principal Analyst Sterling Perrin. Sterling?
Thank you, Beth. And hello, welcome everybody to today's webinar on Efficient Path and Slice Management with Automation, looking at automation in routed networks sponsored by Juniper. And as Beth said, I'll be the host and moderator for today's webinar, and I'm joined, actually pretty excited to have both Juniper as the sponsor as well as guest operator speakers from Orange, Poland joining us today. So I'll introduce our speakers here briefly today, and of course you'll hear from them over the course of the next hour. Very happy to have from the Orange side, Thomas Paczkowski. He is Manager IP Network and Services Development with Orange Poland. Hi Thomas, welcome.
Hi, hello, happy to be here.
Good to have you. And he is joined by his colleague splitting the Orange presentation today, Andrzej Dachowski, who is Network and Service Development Engineer, of course, also with Orange Poland. Hi, Andrzej. Welcome.
Yeah, welcome. Hello. I'm glad to be here.
Great. Great to have you as well. And then last but not least, on the Juniper side, talking through some of the trends and kind of more broadly about Juniper's involvement and what they're seeing with operators will be Julian Luczek, and he is a distinguished engineer with Juniper. Hi, Julian. Welcome.
Hello. Happy to be here.
Great to have you all. So for everybody on the audience, the agenda should show you the flow for the next hour. I'll do a brief introduction, but really then handing things over to our main speakers, Julian covering the state of network automation today in some detail, and then handing things over to our Orange speakers who will give basically the case study of what they're doing in automation, how they're using the technology and why. Julian will wrap up with some additional automation use cases. I'll conclude briefly. And then we do hope to have about 10 minutes or so at the end for Q&A, so please ask questions electronically as they come to you throughout. It's always a good part of the webinar for me and the questions are always great. So looking forward to that at the end. And we also have a couple poll questions, so a few chances to interact for the audience throughout. By way of introduction, really looking at the drivers for and kind of the macro situation with network operators is quite well understood. I don't have a slide for it, but I think we all understand at this point traffic continues to grow. We're well entrenched in the trend of customer demands changing as we move to cloud and on-demand requirements for how services are delivered to both consumers and businesses. And then on the revenue side, although maybe on the OTT side, things can grow quite strongly on the revenue side for the network operators, and this is really both mobile and fixed. It doesn't keep up with the traffic growth, and so there's greater and greater demands to increase efficiency and lower costs, and that's really been the situation for quite some time. I think while there's certainly benefits there's trends heading the way of communications providers driven and accelerated by COVID and how networks have been affected. I think still the constraints are going to be still in place. I'd also say the same for 5G. Certainly benefits of operators moving into 5G, but from our research and what we see in our forecast from the Omdia side of the house, the revenue constraints are still going to be there even as traffic grows. And so one of the tools that operators have, not the only one, but I would say an increasingly important one, is to invest in automation. And in our polls and surveys of network operators, these bullet points here tend to be the ones that come to the top. From operator to operator, I would say that the top priorities can change around, but generally it's a mix of these. I think Orange will focus quite a bit on the customer experience benefits, but we also see a lot of interest in simply reducing time to remediate network issues and problems. Some operators see automation as a way to get services out more quickly, some as a way to innovate faster, some of them focused on network efficiency benefits, and then interest in preventing network problems, and I guess that even filters into improving customer experience and differentiation. So a lot of reasons operators are interested in automation. It's accelerating now, really since the past year, and I think as we go into 2021 will be a big year for automation. But the last point I'd like to make before I hand things to Julian is it's not an all-or-one introduction of automation, and I think it's still a point that bears emphasizing as operators start to look at what they can do with automation. It's not simply turning a switch and now you're kind of an end state of a self-driving or fully autonomous network. I've been working on this slide a bit with some help from Juniper this time around, but really trying to show the different phases. And I think, broadly we have 4 buckets, and they progress over time, and they go from lower complexity to greater complexity as we move from left to right on the slide. But really starting with a lot of foundational automation capabilities that need to be put in place before you can build anything on top of the network for automation. And then where we're seeing a lot of interest right now is adoption of analytics and AI, really using different algorithms and technology and interacting with those foundational capabilities to be able to correlate data, provide analysis, and even suggest remedies for network problems and troubleshooting, with the final stage being that the network personnel make the final decision, but really starting to present data to the personnel based on all of these technologies that are being put in place. The next phase, which I think the industry will spend a lot of time on, is moving into closed-loop processes, and Julian will certainly talk about some of those in his presentation of things that's being done today, but I think we'll see more and more as operators become more comfortable moving into closed loop, where the technologies interact and certain actions can be taken by the network without having to move to that step of human interaction at that point. As that proliferates through the network, we get really to the end state, which could be very well many years out, but certainly the end goal is to this fully autonomous or self-driving network where many or most of these processes can be done autonomously, and obviously getting to a much more efficient way to build networks going forward. That does require standardization beyond what we see today and a lot of acceptance of open APIs across operators globally. The last point I'll make before I hand it to Julian is, we also in the 5G world talk quite a bit these days about network slicing, and I would put end-to-end slicing probably in that third bucket of closed-loop processes trend or stage. So we are going to see a lot of operators driving towards slicing, and the automation is a key piece, of course, to achieving that. With that introduction, let me bring in Julian to provide some additional detail and how Juniper fits in. Julian?
Thank you very much, Sterling. What I'd like to do, first of all, is to introduce the NorthStar controller, because this forms the centerpiece of today's webinar. Now, the NorthStar controller is Juniper's SDN controller for the wide area network, and it's a live controller coupled to the production network and forms part of the control plane of the network, as opposed to being a passive management tool or something like that. And it receives inputs from 3 sources, as shown by those blue arrows. So from the network itself, NorthStar receives a rich variety of information, which gives NorthStar a very good degree of visibility of what is happening in the network right now. So first of all, from a protocol known as BGP-LS, NorthStar can see the current topology of the network, which includes the layout of the links and nodes and attributes of each link, such as IGP metrics and what is the size of each link. Also, it receives a lot of streaming telemetry information related to traffic levels around the network, link delays, and link packet loss ratios. And also it can see the status of traffic-engineered LSPs, label-switched paths, via a protocol known as PSEP. And so in that way, NorthStar can see if an LSP is up or down, and it can see the path that it follows through the network. Also, NorthStar receives inputs from a human being via a user interface, and also requests from an orchestrator via a northbound REST API. And on the basis of those inputs, NorthStar makes decisions about the paths that traffic-engineered LSPs should take across the network. And those LSPs can either be RSVP signaled or can be segment-routed LSPs. Either way, NorthStar creates them via the PSEP protocol, so it sends a PSEP message to the ingress router saying what the precise path of the LSP should be and other attributes, and the ingress router then instantiates that across the network. And during the lifetime of the LSP, NorthStar may need to alter the path of an LSP. That might be due to planned maintenance or due to an emergency maintenance, or it could be in response to conditions that it observes on the network. So for example, if NorthStar sees that a link is getting rather heavily loaded, it can arrange to move some LSPs away in order to ease the congestion, and it does that fully automatically without any human intervention. So that type of closed-loop automation is something that is worth examining in a bit more detail. So this diagram shows a feedback loop. So it's a classical feedback loop diagram, and if you ignore the labels on the diagram, this is something that you see in many areas of technology. So it could be, for example, the air conditioning system in a building where the controller is measuring the temperature in a room and adjusting the temperature of the airflow accordingly. In the NorthStar case, what is happening is that the user requirements are coming in from the left, and NorthStar, on the basis of those requirements, is performing path computation of traffic-engineered LSPs and instantiating those into the network. But as you know, the network is not a static entity. It's more like a living creature, and so it's prone to disturbances, things like links going down, traffic patterns changing, threatening to cause congestion. And so it's very important that NorthStar has a very high degree of visibility of what is happening in the network right now. And it achieves that using the protocols that I mentioned, BGP-LS and PSEP, and also achieves that through the streaming telemetry information, which tells NorthStar how much traffic is traveling along each physical link, how much traffic is traveling along each traffic-engineered LSP, link latency data, and also packet loss statistics. And so all of those parameters close the feedback loop. And so on the basis of that feedback, NorthStar can tune the paths of the traffic-engineered LSPs according to the observed conditions. And so this is really the first time that we're seeing closed-loop automation in earnest in packet networks. And as such, we believe it's a key stepping stone towards a self-driving network. And at that point, when you have the self-driving network, the network's running fully autonomously, as Sterling described in the introduction. What I would like to do now is introduce another automation platform, Healthbot, because we will allude to Healthbot again during the course of this webinar. So Healthbot is Juniper's network element health monitoring platform. And so if you look at the left-hand side of the slide, it is capable of ingesting information from network elements using a wide variety of methods. It can ingest from a Kafka bus, it can ingest via streaming telemetry, via netconf, and a variety of other methods that you can see on the slide. And then what one can do is domain experts can write playbooks that customize behaviors that Healthbot carries out in according to the observed parameters that it's receiving from the network, which could be on the basis of combinations of parameters. And to aid that process, Healthbot also incorporates some machine learning algorithms. So on the one hand, it's capable of performing outlier detection. So an example of outlier detection is if you have a population of devices and Healthbot is monitoring some particular parameters, for example, the CPU utilization. And if across those devices the CPU utilization is around 10 or 20%, but one device is for a prolonged period of time running at 80%, then that's automatically detected as an outlier, and Healthbot can take action accordingly. Similarly, anomaly detection is when Healthbot is monitoring a particular parameter over the course of time. So, for example, it might be monitoring the number of prefixes received from a BGP peer, and perhaps over the course of the days and weeks, this is normally around 10,000 prefixes. If that suddenly dips down to 2,000, then that's an anomaly, and Healthbot can also take actions on the basis of that. And then on the right-hand side of the slide, you can see actions that Healthbot can take triggered by observed conditions on the network. It can publish to a Kafka bus, it can publish to a Slack channel, but also very interestingly, it can send REST calls to other systems. And later on in the webinar, we'll be looking at automated self-healing use case where Healthbot and NorthStar work together to achieve automated self-healing in networks. So with that, I will hand back to Sterling for the first of the poll surveys.
Great. Yep. Thank you, Julian. And we do have our first poll question, so it should be up for everybody in attendance. I'll read it out and then just take a few moments to gather everyone's responses. We'll push out the results and see what comes of it. But at this point, we're trying to get a sense of where our service providers in implementing network automation at this stage. And of course, it's a pick one. If you're a service provider, answer for what you're doing in your own network. Of course, we have others in attendance who are suppliers and different members of the ecosystem around service providers. So in that case, just answer from what you're seeing in your own customer interactions. But we're trying to get a sense of where service providers are. Not started, testing phase, or having implemented automation in some areas of the network, so kind of fairly early commercialization, or well entrenched, having deployed automation solutions in all areas of our network. And while we wait, just to give a moment, Julian, just one question for you, separate from the poll. I had mentioned the closed loop process as being more of a stage 3 development. I'm certainly seeing a lot of stage 1 and stage 2 automation, but I'm curious, that closed loop process, how common do you see that with your customers today? Do you have, can you point to commercial deployments, or are you saying operators are, kind of more kicking the tires around closed loop?
Yes, it has started. So with our NorthStar controller, for example, there are a couple of operators who've deployed automated congestion avoidance, where NorthStar can see how much traffic is on each physical link, and one can set a congestion threshold, a sort of comfort threshold, which perhaps could be 80 or 85% by way of example. And then if through telemetry NorthStar can see that a link is approaching that threshold, it knows, of course, which traffic engineered LSPs are passing through that link, and also it knows how much traffic is traveling along each of those LSPs. And so it has all of the information it needs to actually work out which LSPs are best to move away to ease the congestion. It recomputes their paths, sends PSEP messages to the ingress routers of those LSPs, and so those LSPs are moved away. And as a consequence, without any human intervention, the congestion has been eased on that link. So, as I say, that's something that a couple of operators have been using in live production for more than a year now.
Good. Yeah, certainly makes sense. A good place to start for closed loop. So I did push out the results. Let me do one last push, but I don't think it'll change. Yeah, so half of the audience, a little over, implementing in some areas of the network, a little over a third testing, very few and widely deployed across, which, to me, I didn't expect that to be a high number. But curious, Julian, your thoughts on how the results came in. Is this how you expected?
This is congruent with what I've been seeing. Most people are in the middle of the spectrum, as we can see here. As you can see from the results, almost everybody has started. There are a few exceptions in the survey. And then ubiquitous automation is relatively rare, which we can see from the survey as well. So certainly most operators are somewhere in that middle ground, as the survey also shows.
All right. Yeah. Excellent. Well, let's keep moving, but interesting results. And we'll bring in Orange to continue. And I believe, Thomas, you'd be the first speaker from Orange. So I'll hand things over to you to continue.
Thanks, Sterling. I'm going to share with the audience our experience of deploying NorthStar Controller in our network. In the context of automation, of bigger automation picture in our network, I'm going to talk a little bit how we implemented it and what benefits it brought to us and what next steps we're going to do. So originally, the need for network controller, or specifically the solution for network automation, right from the big number of construction works in Poland on railroads, on roads, who were carried out previous years, and due to the situation, we experienced a lot of fiber cut. And for improved resiliency of our network, especially our mobile traffic transmission, we decided to implement the solution that is capable to maintain the path diversity. So historically our primary driver was network resilience and reliability. But apart from that, we've seen a lot of other benefits that this solution, or this kind of solution, could bring to us. Our major concern now is customer experience, which is represented with NPS, which stands for Net Promoter Score. I would say customer satisfaction is our obsession now. Apart from that, we were looking for the agility to create network resources or network services for the future deployments, especially for 5G, which we expect it will be the massive deployments of network services. We're also looking for improving the quality of our network operations. And last but not least, we're looking for solutions to help to facilitate network transformation. All of you who are service providers might imagine that we as an incumbent have a huge burden of legacy technologies, and this could be solved by using of this kind of solution. NorthStar Controller, who was described by Julian, we implemented it for IP/MPLS network originally, and this is the place that it's working now. But it's worth to remember that it is a piece in a more global picture of service automation and orchestration. It provides us with the functionalities that Julian described, and functionalities were adapted to our needs. And now I'm going to hand it over to Andrzej, who is going to describe our use cases.
Okay, thanks. Okay, so as Tomasz mentioned, a very important driver for this project was network resilience and reliability. And one way how we can improve it is to use PC controller because it can be helpful in some situation. So for Orange Polska, the first use case for NorthStar was to address complexity of transport provided for mobile services. So many mobile platforms are using IP/MPLS network for connectivity, and these platforms require end-to-end disjointed transmission paths, so that single failure or maintenance window can affect only one of them. In example of the slide, we want to provide two separated paths. And if we rely only on IGP, we might end up with two paths going through the same link, the bottom example. So the solution to that is to use traffic engineering, and we can do it either by changing. So we can do it either by changing configuration on the devices, what might be time-consuming and prone to errors because we have to find out what is the IP address of each link and configure it for each and every link on the path. Or we can use PC controller, which has complete knowledge of the network topology and computes the paths and sends instruction to ingress routers how the paths must go through the network according to logic we were able to define. And it might look simple on this slide, but just imagine that you have not 10 but 100 of devices, and instead of two paths, there are hundreds of paths. So it's not easy to manage and maintain this kind of network complexity, especially when network is changing because of deployment of new routers, new links. When you manage it by changing static configuration, it's of course possible to do it, but it's time consuming, and it might be easy to oversee something and configure the path in non-optimal way without the business logic which is required. And provisioning these two disjointed bidirectional paths is out of the box feature of NorthStar, which is called diverse LSP. Okay, so the second use case is to use NorthStar application for maintenance window, which allows us to plan that link or node will be out of service for some specific time in the future, and all LSP paths controlled by NorthStar will be rerouted on different links to avoid the one affected by maintenance event. So it can be set by UI, by human, using UI by human operator for events like upgrading operating system on the router, and it's also used internally for marking links with packet loss. So it's simple functionality, but quite powerful when you combine it with feedback from the network. So it's already done for packet loss, but as Julian showed you, using REST API, we can react to anything what can be get from the network devices or from other systems. So I think after we integrate NorthStar with Healthbot, one possible use case will be to recognize and react on traffic backhauling, which might happen during hardware failure. So Healthbot will recognize using telemetry that there is some problem with line cards or fabric, and NorthStar will set maintenance event for specific links related to these line cards or for the whole device. Okay, so next use case is bandwidth on demand. it's an idea to provide additional bandwidth between two endpoints by creating additional path, which is going through another links than the first path. So most networks are designed in a way to be resistant to a single point of failure, and this approach requires redundancy on the links level, and most of the time network or some part of the network is operating without any failure. So this redundant bandwidth is available and could be temporarily used. And like in this case, by provisioning additional LSP between PE2 and PE4, we can have instead of, for example, 100G, we can double it by providing provisioning this additional LSP, and we can do it for some specific event or for some specific hours on daily basis. And we might don't want to have this additional path all the time because, for example, the delay is bigger than for the origin one. But when you have some temporary event or failure, it might be better to increase delay for half of the traffic than deal with congestion in the network. And creating this additional LSP is much easier to do with NorthStar rather than using CLI, because in NorthStar we already have built-in analytics, so we know the volume of the traffic for physical and logical links, as well as for each and every LSP in the network. So, and additionally, we have this topology overview, so we can preview how the path will be going through the network. Okay, and the last but not least, closed loop automation. So all previous use cases are possible to do without external controller. But if our goal is to save time and prevent human errors, the PC controller like NorthStar is right tool to use for these cases. But the use case you are seeing now is impossible to do without external controller, because we are talking here about something what is happening in a loop between network and the PC controller. So NorthStar has visibility of network topology and paths going through this network, and if this information is enriched by performance data from telemetry, NorthStar can detect congestions or packet loss and react to optimize the traffic. So in this simple topology, we can see congestion on one link and packet loss on another link, and if LSP, which is going through this congested link, is externally controlled, it can be rerouted, and if possible, links without congestion or packet loss will be chosen for this LSP, as you can see on the top. So this idea of combining performance data with LSP management is really helpful and powerful, especially while you're dealing with network faults, and especially when you have aggregated links as we do. Imagine that this link between P5 and P7 is 200G aggregated link, and that we lost one member of this link. So instead of 200G, we have 100G capacity, and there is always this question if it's better to leave it or shut it down. When you leave it, you might end up with congestion, like on the picture. When you shut it down, you lose redundancy. So when you deal with these problems by static configuration, like setting minimum links to 1 or set it to 2, it's not so efficient. But when you use closed loop automation, a lot of these situations can be solved automatically and more efficient, because you can avoid congestion and at the same time let this one working link carrying part of the traffic. Okay, so how do we implement it in Orange Polska? Our IP-MPLS network is designed in a way that even if we lose communication to NorthStar, network will still carry the traffic using some default paths based on IGP. And what is important and been tested, when a PC-initiated LSP is timed out and the traffic is switched to the default one, there is no packet loss. So and these default LSP still have features like link protection. So what I'm trying to say that network should be prepared for losing communication to the controller, but we don't want to lose it anyway. And this is why we use HA cluster. And in our case, the cluster is composed with 3 nodes. Each node is in different geographical location and is connected to EVPN bridge domain using 2 different PE from the network side. And the cluster in general is can lose 1 node, and the application will still be working fine with full functionality. So in general, for us, NorthStar is an application which puts additional centralized control layer, and thanks to this additional layer, the network can offer additional functionality, like this diverse LSP UI or REST API for LSP provisioning, or something what can be called self-healing network using closed loop automation. So it's a big change for us, but the idea from the beginning, the idea behind this implementation was that if we lose controller, we lose only these additional functionalities, and this is how it was implemented in Orange Polska. Okay, so Tomasz, can you please summarize the benefits?
Okay. Thanks, Andrzej, for our use cases description. Now I would like to briefly summarize the benefits that were brought by introducing the solution. So, as you can see, we introduced a fully resilient solution that brought an excellence to our network resilience and reliability by maintaining the path diversity, which was our original use case, but also by isolating the part of the network for maintenance, for example, for path provisioning according to different constraints. For example, optimizing delay optimized path or path or traffic securization in case of link overlay or of link overload. After implementing the Healthbot, which is under deployment now, we hope to reach the closed-loop automation functionality. Of course, bandwidth on demand, it's not our last requirement, because we want to be ready for addressing the bandwidth requirements for sports events, for example. This network also brought us the clear visibility of network flows in the traffic flows in the network. Thanks to this, we are able to more precisely design our network and capacity extensions. And of course, for network and engineering teams, it brought new competencies, and these competencies are vital on our path towards full automation and orchestration of the network. As far as next steps are concerned, so in short term, we would like to introduce more fractions of traffic under NorthStar supervision, because as I mentioned, now we supervise the traffic for mobile core. For midterm, we're considering introducing the NorthStar controller or network controller in general for more network domains to provide more end-to-end visibility of the network resources. We are considering how network controller can help in a massive deployment of services for 5G. And finally, for long term, after introducing Healthbot telemetry machine learning algorithm, we hope to reach the stage of self-healing network. And thanks a lot for the possibility to present our deployment. I think now we switch to Julian again.
Thank you very much, Tomasz. What I'd like to talk about now is some additional use cases that NorthStar supports. So first of all, let's have a look at automated peering engineering. So now we're looking at the peering layer, how from your network you send traffic out to various ASs that you're peering with, and also in a reverse direction, how traffic comes from other ASs into your network across the available peering links and ASBRs that you have. And so NorthStar can control this process. And so to aid this, NorthStar receives flow information from the network nodes in IPFix format, telling NorthStar about the inflows and outflows of traffic into and out of the network. And so on the diagram, I'm showing how various PEs in one's own network is sending traffic to a particular prefix X, which is potentially several AS hops away across the internet. And so NorthStar from the IPFix information can see how it's flowing out of the network. And you can see that various PEs are using various ASBRs and various peering links on them. And so if a peering link is approaching congestion, then NorthStar can move some flows onto a different peering link. And so, for example, suppose given all of the flows that are using the link from ASBR1 to ASBRE towards the left-hand side of the diagram, suppose that link's getting rather congested, NorthStar can arrange to shift some outbound flows across. And so, for example, if you look at that red flow going from PE2 to prefix X, NorthStar has shifted it across to ASBR2. The way it does that is, first of all, to shift the flow to ASBR2 rather than ASBR1 in the first place. NorthStar is manipulating BGP attributes of the prefix X as seen by the devices in the network. And then it's using an ingredient from segment routing, it's using peercids in order to select a particular peering link out of ASBR2 to one of the remote peers. So that's how the egress peering engineering works. And then similarly, in the reverse direction, ingress peering engineering, NorthStar can also influence those flows. And it achieves that by altering the outbound BGP policies. And so it adds policy statements to the BGP policies, for example, as advertised by ASBR2 to the ASBRs that it peers with. And so if we want to deflect a flow onto a different peering link, we make the existing peering link less favorable by, for example, adding to the AS path length of the BGP advertisement or adding a less favorable MED. And so as you can see overall, NorthStar in both the inbound and outbound direction can control the way the traffic flows into and out of your network. Traditionally, of course, this is something that's done in quite a manual way, so having it happen in this automated fashion makes life a lot easier. Another very interesting use case that we alluded to before is automated self-healing. And so this is where Healthbot and NorthStar cooperate to achieve the self-healing. And so I mentioned before that Healthbot is able to ascertain the health of network elements. And so suppose that node R1 has some problem associated with it. Healthbot realizes that. And so the first thing it does is it sends a REST call to NorthStar, asking NorthStar to do a simulation. And that simulation is a simulation of what would happen if node R1 hypothetically were to be taken out of service. Is it still possible to accommodate all of the traffic flows that are going around the network? And NorthStar replies to that REST call, and if it replies positively, as in it is possible to accommodate all of the traffic even without node 1 in service, node R1, then Healthbot then takes the next step, which is to send a REST call to NorthStar asking for an immediate maintenance window to be created on NorthStar on router R1. And what that does in turn is to trigger NorthStar to recompute the paths of all of the traffic engineered LSPs that are passing through node R1. And so it sends the new paths to the respective ingress routers. And so in that way, router R1 is drained of traffic. And so then one can investigate what's the problem with R1 without the danger of affecting production traffic. Now, normally, self-healing, traditionally, that's a rather manual process. Somebody has to actually, realize that there's something wrong with a particular network element, and then they need to work out how to divert the traffic, and then they need to reconfigure some of the routers in the network. And so that is quite time-consuming and also somewhat error-prone. So having it happen in this fully automatic way, of course, reduces the time that traffic is passing through a faulty network element, and so overall it improves the SLAs as seen by the end customers. And so now the final use case that I'd like to look at is 5G network slicing across the telco cloud and the wide area network. And so on the left-hand side of the slide, you can see a data center, and also you can see an SDN controller, our Contrail controller, and that's our controller for cloud overlay networking. And so what Contrail does is it creates virtual networks to interconnect groups of virtual machines or containers that reside on the compute resources that you can see on the far left-hand side of the diagram. And each virtual network represents a slice, if you wish, at the telco cloud layer. And then on the right-hand side, we've got the wide area network under the control of NorthStar. Now, suppose the green and purple virtual networks, or the green and purple slices, need low latency transport across the wide area network, while the yellow slice just needs lowest monetary cost transport. Contrail can arrange for traffic to be coupled into the appropriate type of LSP in the wide area network by simply advertising corresponding tags or communities in its BGP messages that it injects into the wide area network. And so those community tags actually trigger routers in the wide area network to put traffic onto the appropriate type of LSP when sending traffic into the data center across the wide area network. And so as you can see on the diagram, traffic belonging to the green and the purple slices uses the minimum latency LSP, while traffic belonging to the yellow slice uses the minimum cost LSP. And so in this way, we've extended slicing right across the telco cloud and the wide area network. Now, finally, if you want to see how this scheme fits into the wider picture of end-to-end slicing, including the radio network, then the link at the bottom of the slide is a pointer to our virtual exhibit on the O-RAN Alliance website that talks about this. This is a virtual exhibit that we posted within the last few days that has a lot more details about this particular use case. And so with that, I will hand over to Sterling, who will now lead the final part of the webinar.
Yes, thank you. So we will now move into our second poll, and we are getting to the end. I know some questions have come in. which is great. Now is definitely the time to ask. So if you do have questions, fire those away electronically now. We'll get through as many as we can in the next 9-10 minutes or so. In the meantime, let me go through the poll question here, which should be up in front of everybody. What use cases are most relevant for service providers? So again, if you're a service provider yourself, what are the automation use cases that you are most interested in? If you're a supplier into the industry, then based on your interactions with customers, which ones are coming up most often? This one is choose multiple options, so as many as apply, and there's quite a few, as you can see. You might have to scroll down, see them all. I do. So path diversity, maintenance window, bandwidth on demand, link congestion avoidance, peer engineering, network self-healing, slicing across telco cloud and wide area network, or minimum path delay. I believe between Orange and Julian, they've kind of walked through each of those in a little bit of detail. We're curious your views. While we wait for a consensus on response, Julian, one question had come in. You don't need to spend a lot of time on it, but just in terms of clarification, somebody did ask about the SDN controller that Juniper is using to build the NorthStar architecture. So maybe just a quick clarification on that, and then maybe we can...
Sure. Yes. I mean, NorthStar is created completely in-house. So all of the ingredients, come as an in-house development within Juniper. So that includes, for example, the path computation algorithms, the protocol implementation, for example, BGP-LS and PSEP that we talked about during the course of today's session, the logic for processing telemetry and so on. So it's an entirely, internal development, in fact.
Okay, great. Thanks for that clarification. Here's the results of the poll. Yes, so it was pick multiple, so we'll definitely get some over 50%. It looks like path diversity, link congestion avoidance, minimum path delay, all got 60% plus, and then kind of a mix. Most of them had at least some fair amount of interest. So pretty broad spectrum. Any thoughts on the results, Julian?
Yes, certainly the path diversity, which came out tops, that is a popular use case of NorthStar. Achieving path diversity without a central controller is difficult, because if you're asking the routers to compute the paths themselves, and one router's the head end of one of the paths of the pair and another router's the other head end, then there's no mechanism for the routers to confer, and so it's just down to luck whether the paths end up diverse or not, unless you completely nail them down, but that's problematic in itself. In contrast, if you ask the controller to compute the paths, you tell the controller, okay, I've got these two paths that I want them to be diverse, you now compute the paths, and it does simultaneous path computation in such a way that they are indeed diverse. So it does solve what used to be quite a headache, actually, with network engineering. The link congestion avoidance, yes, again, that is a popular one, because congestion management is a perennial problem in networks, and doing it manually is quite an effort. People have to monitor link utilizations, and then they have to work out how to move traffic if a link is getting rather congested. So it is quite a tricky thing to do. You end up having to reconfigure routers, and errors can happen there. So certainly having it happen fully automatically is very advantageous. And I mentioned earlier on about a couple of operators who've been using this in production with NorthStar for more than a year now.
All right, excellent, thanks. We got about 5 minutes left. So this is the conclusion slide. I'm just going to leave it up here in the interest of time, and just dive into some of the questions, because we've got some good ones in. Question came in. This is really for Orange, I believe. Question is, did you take into, so based on your presentation on your use cases, did you take into account geospatial fiber data and shared risk link groups, SRLG, to determine path diversity? So just some additional interest in what you considered.
Yes. So this path diversity, which can be computed by NorthStar, can take into account SLG, of course, configure on the link, and this is must because the goal is to avoid fiber which is shared by different logical links. So this is a must, and this is how it's done. Yeah.
Okay, great. Question. Question. I guess this is for Juniper. Can you talk about an application of path diversity? So I guess some detail on.
Yes, sure. One application is for mobile signaling traffic, as Andrzej mentioned during his presentation. Another one is as a replacement for private circuits, because in the old days people used to have SDH or SONET-based private circuits, and as a matter of course you could order them as a diverse pair as a service option. And so with people having moved to MPLS packet-based infrastructure, they need to offer a similar style of service. And so typically these are implemented as point-to-point layer 2 pseudo-wires, and those pseudo-wires need to be diverse, and so they need to be underpinned by pairs of diversely routed LSPs. So that's actually quite a popular application of path diversity. In fact,
yeah, I can just add that.
Go ahead.
For example, EPC elements like MME, packet gateway, PCRF are in our network are using these two separated paths for communication with diameter DSR router, and these platforms are using STTP protocol on these two paths to ensure that if one path is affected by any problem, traffic will be switched to the other one. So it's very important not to have any common links for these two separated LSP paths.
All right. We probably have time for 2 questions left, and this one did have to do with Orange, the Orange presentation. You talked about the high availability, and there was a particular slide. Somebody's curious if it's an active high availability cluster that you've created.
Yes, so it's active standby because PCAP sessions can be established only to one active node. So it's working in active standby mode, and the failover in the cluster, it takes like 5 minutes, and in our case, this LSP provisioned by PC controller can be in this mode, orphaned mode, for 30 minutes. So it's good time to wait for failover, and then another node is active, and PCAP sessions are established to the other one. So, but I don't know if it's possible to do it in active, but our implementation is active standby.
All right, and so for the audience, there should be a brief survey that's up in front of you. If you can take a moment to take that survey, your feedback on the webinar before you close out, we would definitely appreciate that. And the final question, because we're at the top of the hour, Julian, question, you talked about a number of protocols. Question is BGP LS and the PCEP protocols that you talked about, are they standards-based, or is there some kind of proprietary implementation involved in using those?
They are standards-based, so they are both described in IETF drafts and RFCs, and so those protocols interop across vendors, and there have been interop tests, for example, hosted by EANTC, to show interop of these protocols in practice.
Okay, that brings us to the top of the hour. I know there's some additional questions, and I believe our presenters can just follow up one-on-one post-webinar to address some of those. but that's all that we have time for today. So I want to thank all of our presenters. Of course, thank you to Juniper for sponsoring, and thank you to everyone in the audience for tuning in. This closes out the webinar. Thank you, and enjoy the rest of your day, everybody. Goodbye.
Thank you, Sterling.
Thank you.
Thank you all.
Bye-bye.
Thank you.